Hi, I am Miguel Torres Caballero, and my number of identification is A01 42 46 85. I'm going to solve the argumentative oral exam, and this is the argumentative oral presentation that I made. First, the problem said us that we need to determine the Vx and Ix. The Vx is right here, and the Ix is right here from the problem. The problem gives us the I1, that is this one, with 46, and the R with 16, that is this one. So first, we have we need to have a supernode, that is this one, and we are going to find the equation of the supernode. So I'm gonna base my presentation from my equation that I already did. So first we have B3 minus B2 equals 15 Ix. And the other equation we have is Ix equals minus B3 divided by 1. This is because we have all here in this part. So we need to simplify this equation. So we simplify it by having B3 minus B2 equal 15 times minus B3. This is like putting together the two equations that are these two, because the with the points of the nodes here is B2 and here is B3. And so simplifying this, we have our first equation, that is B2 minus 1 plus B3 equal times 16 equals to 0. So this is our first equation, or the first like important equation that we are going to use for solving this problem. I'm just going to check if it's good. Yes, it is good. So we have first equation. Now we need to have the equation for B2 and B3 for having B1. So we have the nodes B2, B3, and B1, and we are going to have this equation that is B2 minus B1 divided by 6, that is the ohms, 6 ohms, minus 46. Now this 46, we have it right here in the I1 from that the problem gives us. So let's continue with minus Bx, the x times, divided by 8 plus B2 divided by 16 plus B3 minus B1 divided to 6. So as we can see, this equation is long, so we need to simplify it and do it like easier to find a solution. So we're going to simplify this equation by doing this. I'm going to pass this, and I'm going to put it right here. So now we have the simplification by having B1 times minus 1 divided by 6 minus 1 divided by 6 plus B2 times times 1 divided by 6 plus 1 divided by 16 by 16 plus b3 times okay, b3 times 1 divided by 6 plus 1 plus bx plus, times 1 divided by 8 equal 46. That continue is the 46 that the problem gives us. So now this still is still an equation that we can solve, or well, is difficult to solve. So we are going to simplify it to having this equation that is, first, now we can see here that we have two four incognites, that is b1, b2, b3, and bx. So now we need to substitute bx with this equation, that is px equals b2 minus b1. So this is like the formula for us to have it more easier. So I'm going to put it right here. I'm going to use this equation to, this formula to substitute bx into here. And now we're going to have b1 times minus 2, 6 plus 1 divided by 8 plus b2 times 1 divided by 6 plus 1 divided by 6 minus 1 divided by 8 close parentheses plus b3 times 1 divided by 6 plus 1, and that equals to 46. So now we have the second equation, and as we can see here, we only have now b1, b2, and b3, the three nulls that that we have here. You can see. So now this is our second equation. That if we have it here, we have the first one and the second equations. Now we are going to have the equation for b1, because as we can see, we have b1 here, but we are going to just solving from b2 and b3. So for this, we are going to have b1 minus b2 divided by 6 plus 46 plus b1 minus b3 divided by 6 equals to 0. Okay, so this is our first equation for b1, but we can still simplify it more. So we're going to do this a little bit short, and we're going to just simplify this equation by having b1 times 1 divided by 6 plus 1 divided by 6 plus b2 times 1 divided by, I'm sorry, minus 1 divided by 6 plus b3 times minus 1 divided by 6 equals 46. b1 b3, yes. Now here it missed a parenthesis. So this now we have the third equation that give us this, the three equations. Now we're going to pass this equation to the matrix that give us this matrix, and this is the amplitude matrix, because here we have the zeros, the 0 in the V1, 1 in the V2, 16 in the V3, and the 0 as the result. We can see it all the way here. And we are going to put this in a program from Gauss-Jordan to have the solution as we can have it, and we can see it right here. This is the solution, and we have here the solution, but I have it already here. So this is the solution of the Gauss-Jordan, and we are going to put it x like is b1, x2 b2, and x3 is b3. So we divide these numbers, and b1 give us 1.042, and x2 or v2 1.784, and b3 0.106. So for the solution and the final solution, we're going to use these two formulas, that is b2 minus b1 for bx, and for ix is going to be b3 times 1. So we're going to start first. I already do the solution right here, but I'm going to explain. Ix divided by 1, well, is everything divided by 1 is the same number, so you 0.160, and the Vx, V2, that is this one, minus this one, that is minus 1, give us this one, the Vx. So now we can conclude and say that, so now we conclude that the Vx is this solution. Thank you.